Hi children, welcome to our channel. This is Mr. V. Srinivas, School Assistant Physical Science, working at Government High School, Sanatnar World, Balanagar Mandal, Mechal District. Our lesson is electromagnetism. In this video, now we are going to discuss about Faraday's law. Before watching this video, I request all my dear students to subscribe our channel and I request you to share to your friends so that you will get good videos in your future and related videos you will get, my dear students. So subscribe the channel before watching the video. And what is Faraday's law? The induced EMF, electromotive force generated in a closed loop, is equal to the rate of change of magnetic flux passing through it. The induced EMF generated in a closed loop is equal to the rate of change of magnetic flux passing through it. My dear students, just by reading this you can't understand. After explaining with figure, you can come to know what is the meaning of this sentence. So before entering, you should know what is meant by magnetic flux. The number of magnetic force lines is called magnetic flux. My dear students, you try to keep in your mind, the number of magnetic field lines is called magnetic flux. Okay, my dear children, this electromagnetic induction is demonstrated by using one experiment, and the picture or figure you are observing that one copper coil is there. The ends of this copper coil is connected to G. G means galvanometer. Here you have to know what is meant by galvanometer. That galvanometer is to use or to detect the current. It is the current detector. So it is connected to that galvanometer. When this coil is connected to the galvanometer, we can observe that there is no deflection in the galvanometer because no current is there. When a bar magnet is bring near to this coil, we can observe there is a small deflection in the galvanometer. Deflection is galvanometer means there is some current. So when bar magnet is brought towards the coil, we can observe that there is a deflection in the galvanometer. Now you keep it at the same place, that magnet, we can observe that there will be no deflection in the galvanometer. Now take away that bar magnet from the coil, then we can observe that there is a deflection in the galvanometer in opposite direction. My dear students, just you observe that when bar magnet is brought near to the coil, there is a deflection. When bar magnet is taken away from the coil, then also we can observe there is a deflection in the galvanometer. Whereas when bar magnet is in stationary position, we can observe there will be no deflection in the galvanometer. That means there is no movement in the bar magnet, there is no deflection in the galvanometer. That means when bar magnet and coil, both they are having relative motion. They are in relative motion. That means there is a movement in bar magnet, there is no movement in the coil. In that position, there is deflection in the galvanometer. Deflection in the galvanometer means there is some current. How the current is produced here? Actually, that coil is not connected to any battery. That current is induced by this magnet. When magnet is in the movement, then only that current is produced. That current is called induced current. My dear children, repeat this experiment with the south pole also. Then also you can observe that there is a deflection in the galvanometer, that means current is induced. But only one difference is the current which is produced here in opposite direction. Whatever the direction of current, it is none of business. But current is produced there. When there is relative motion between coil and bar magnet. Repeat the same experiment that bar magnet should be at stationary position and this loop or this coil should be in movement. Then also we can observe that there will be deflection in the galvanometer. That means current is induced in that coil. That means we can conclude that there should be relative motion between these two. Then current is produced. Current is produced, my dear children. Then why it is happening, we should know, my dear children. When bar magnet is nearer to that coil, the magnetic flux, that means forceful lines. These forceful lines are intersecting that coil. Due to those intersecting of the forceful lines, this current is induced. And there should be change in that magnetic flux. That flux, that means the number of magnetic forceful lines intersecting this coil. And there is a change in that magnetic flux. How the change occur here? When bar magnet is brought nearer to the coil, slowly its flux is increased. That means flux is changed. Similarly, when it is brought away from that, slowly the magnetic flux is decreased. That means there is change. So we can conclude that to produce the current, there should be a change in the magnetic flux. So this experiment demonstrated like this. Okay, then the induced EMF is depend upon following factors, my dear children. The number one is strong magnet. That means here magnet is strong, the induced EMF is also increased. And second one, motion of the magnet. Here when magnet is in the movement, if movement that means its speed or velocity will be increased, then EMF is also will be increased, my dear friends. And the third one, area or number of turns of the coil. If area of the coil is increased or number of turns of copper wire will be increased, then induced EMF is also increased, my dear students. My dear students, observe this. In mathematical form, we can write this as induced EMF is equal to change in flux by time. My dear students, mathematically we can write that induced EMF. Induced EMF is equal to change in flux by time. Okay, this induced EMF is denoted by epsilon. Epsilon, Greek letter, is equal to delta phi by delta t. This equation is called Faraday's law of induction. Here, delta phi is change in flux. Delta t is the time taken for that. Here in the if delta phi is taken or delta phi not is taken, then there is single turn in the coil. If more turns, 2 turns, 2 phi naught, 3 turns, 3 phi naught, like that n turns are there, then we can write n why not. So this equation is called Faraday's law of induction, my dear students. Okay, thank you, my dear children. All the best. You go through this video for 2 to 3 times. You may not understand any lesson by listening or by watching single time. We should watch any video for 2 to 3 times, then we come to know everything, and you will be in a position to write the answer without helping any textbook, my dear children. All the best. God bless.